So let's just start our technical session. Hello everyone. So our today's topic is pumps. So we'll start from pumps. The first question is what is a pump? Let's start from the basics. What is a pump? Can anybody explain what is a pump? Can anybody give me the definition? Anyone? So I will just give the definition of a pump. A pump is a device that is used to transfer liquid from one place to another by using a mechanical means. So this is the definition of pump. Then going on to the classifications of pump, the types, what are the different types of pumps? Anybody wants to answer this question, or should I just go on explaining the different types of pumps?
Am I?
Yeah, yes, Ashok.
There are two types of pump. One is reciprocating pump, and then rotary pump. Which reciprocating pump is subdivided into rotodynamic and then reciprocating pump. One is single acting piston pump and diaphragm pump and double acting piston pump, and then rotodynamic pump was screw pump and then screw pump, gear pump, and then that's it. And then one is another type is centrifugal pump and then axial flow pump.
So you have given the names of the pump, but the types were wrong. Like there are two types of pump. The first one is rotodynamic pumps and positive displacement pump. So these are the two types of pumps. And in rotodynamic pumps, we have centrifugal pumps and axial flow pumps. In positive displacement pumps, we have reciprocating pumps and rotary pumps. In reciprocating pumps, we have diaphragm pumps and single acting and piston pumps. In piston pumps, we have single acting piston pumps and double acting piston pumps. And in rotary pumps, we have uh, gear pump, a screw pump, a vane pump. So Ashok, you got it.
Yeah, I got
So
it.
I think you forgot the to mention the rotodynamic and positive displacement at the types, right? At the
Yeah,
starting
yeah,
of the
yeah.
answer. Yes. Okay. So coming, we'll start from centrifugal pumps. What is the centrifugal pump? Anybody?
Am I?
Yeah, go on.
Uh, Basically, centrifugal pump is used to dis- displace a fluid from one place to another, which by means of centrifugal force which act on the fluid. This was the principal act on the fluid, so it's called centrifugal pump. Uh, the working uh, the working of centrifugal pump
First, can you
is,
explain the components first? Then we will
yeah,
move on to the working.
there is a, I will start from the bottom.
Yes.
There is a foot strain valve and then foot valve and then strainer and then eye of an impeller and then casing discharge valve and then uh, seal. There are two types of seal: mechanical sealing and then gland packing sealing, and then shaft and then motor. Now I start the working.
I think
When
just 1 second. I think have you mentioned the lantern ring,
what?
and the priming port?
No, I didn't mention.
Yeah, I think you can mention those two things too. I'll just
Okay.
answer it once again. I will also start from the bottom. First, the strainer and the foot valve. Then the suction pipe. Then the impeller eye, impeller vane. Then the volute casing, the priming port, then the discharge valve, then the shaft and the motor, gland packing or mechanical seal, and lantern ring.
Okay.
Have I named every part or anything is missing?
Yeah, you mentioned everything.
Okay. So yes, now you can explain the working of a centrifugal pump.
Uh, Initially, impeller is surrounded by fluid. When impeller start rotating, fluid also start rotating. Uh, Fluid get displaced. Fluid get displaced radially outward toward the casing. Why? Because of centrifugal force act on the fluid. Centrifugal force act on the fluid and cast out radially outward toward the casing. The fluid get displaced from one place to another. So there is a vacuum pressure created in eye of an impeller. So there is a suction of fluid created in eye of an impeller. So suction happen in the eye of an impeller, and the fluid flow readily output. Sorry, fluid flow circumferentially outward toward the discharge side along with casing. When casing area of casing gradually increases to discharge side, so there is a area increases, velocity decreases according to equation of continuity, and then velocity decreases, pressure energy increases according to Bernoulli's theorem. This is how discharge pressure created in discharge side of the valve.
Yes. While explaining how is the suction pressure getting created, I think you can form the answer a little bit more better, so that it's more easier to understand. And also, how is the discharge pressure getting created? Both, like how is the discharge pressure getting created when the fluid is flowing to the volute casing? The cross-sectional area of the volume or the volume of the volute casing is gradually increasing. So when when liquid is passing through the volute casing, the kinetic energy is, as the area is decreasing, the velocity is decreasing, right? And equation of continuity says that when the area is increasing, the velocity decreases, due to which the kinetic energy is decreasing. And as soon as the kinetic energy is decreasing, the pressure energy is increasing, which is because of Bernoulli's theorem.
Bernoulli's.
Yes, it says that potential energy plus pressure energy plus kinetic energy, it's total sum of the energies is equal to constant, right? And here we are neglecting the just one second, I'll just admit the people we are waiting. And here we are neglecting the height because there's not much of a height difference, right? So we are neglecting the potential energy, correct?
Yeah.
Yes. Anybody else wants to answer this one? Anybody? What's the working of a centrifugal pump? So how is the suction pressure getting created? Anybody? रविराज आंसर करोगे क्या? Suction pressure. How is the suction pressure getting created?
Slightly outside.
Okay, all right. Okay, all right. So how is the suction pressure getting created? So first I will just start from the explain the working from the starting. So when we start the pump, the motor which converts the electrical energy into mechanical energy, correct? So it rotates the shaft, rotating the impeller, and suction is taking place at the eye of the impeller. When the impeller rotates, it pushes the water or liquid that is being already present at the pump radially outwards, away from the axis of its rotation, correct? Due to which a void space is being created at the eye of the impeller. This void space is nothing but the negative pressure region. and as there is atmospheric pressure being applied on the uh, tank or sump, water sump, due to this reason the pressure is higher in the tank. Hello, am I audible now? Hello, am I audible now?
Yeah.
I'm so sorry, the electricity is no more. So I think I will just explain the working of the this one pump. I think the if the current will not be coming, then the session will not be much longer. You guys can continue at that time. But for now, my laptop is little bit still charged. My battery is not the backup is not very long. So what was I speaking regarding the work? Yes, the void space is getting created, right? And the void space is getting created at the eye of the impeller. And since there is higher pressure at the sump, as atmospheric pressure is being applied, so as liquid or fluid passes from higher pressure to lower pressure region, the suction will be taking place at the eye. Am I right? Hello?
What?
Am I right?
Like, the suction pressure was created by displacing the water readily output to the casing.
Yes.
You said that, right?
Yes. The water
Yeah.
that is being already present at the pump, right? So
Yeah.
the impeller will impart centrifugal force and the water will flow radially outward. That is the water that is already being present. If there will be no water, then we need to do priming.
Yeah.
So
There is a two types of priming, manual priming, and then we can use reciprocating pump for priming
for
purpose.
vacuum pump, right? Can you
Yeah.
explain the steps how to perform a manual priming?
There is a priming port. We have to fill the water inside the pump manually.
Yes, first we have to close the discharge valve. Then we have to open the priming port and the air vent. Okay, so
Yeah.
then we have to fill water with the help of the priming port and let the water fill the whole pump. Then we have to close the priming port and then we have to start the pump by keeping the discharge valve shut for that time. And then when we will see that only water is being coming out of the air vent, then we can confirm that priming is done. Then we can close the priming port, the air vent, and open the discharge valve. So this is the steps how to do a manual priming. And for automatic priming on board, we use a vacuum pump. Yes, Vaishak.
How long will be the discharge valve, sir?
How will be the discharge valve shut?
How long? How long?
How long? Maximum
It's
is
15
15 minutes.
minutes.
Yeah, maximum 15 minutes. So yeah, next question. What will happen if the discharge valve is shut for a longer period of time? Can anyone answer what will happen?
I think
More
overheating might
pressure is
happen.
created.
No, the
More pressure is
pressure
created
over.
inside a pump.
Akshay, can you answer it again, please?
The more pressure is created inside the pump, and due to the heavy pressure, the pipes can get damaged.
You are explaining centrifugal pump, right?
Yeah.
So in centrifugal pump, higher pressure cannot be created, right?
Yeah,
Motor winding will be damaged because of the high heat,
So
I think.
yes, yes. So if we will keep the discharge valve shut for a longer period of time, then heating will occur. The casing will get heated as the kinetic energy is not being getting converted into pressure energy. So heating will occur, the casing will being heated up and it will damage the gland packing or mechanical seal, whatever is being used. The pressure will not increase as it is a centrifugal pump. if we will keep the discharge valve shut in a in a positive displacement pump, then the pressure will increase and it will release the relief valve. Then also it will directly not damage the uh, pipings. First, the relief valve will be open. Got it?
Yeah, yeah, got it.
Okay.
What is the function of latent ring?
So the lantern ring is a metal ring which is fitted in between the gland packing. There are three functions of lantern ring. The first one is cooling, the second one is lubricating, and the third one is it protects. The water from the discharge side of the pump gets into the lantern ring, which cools the shaft and the stuffing box, and it lubricates the gland packing. As gland packing is made of fibers, the water seeps through the gland packing, and it protects the lantern ring, acts as a flush point, so that when impurities or dirt can get into the pump through the stuffing box, as it is open and one side is open, right, in the stuffing box, so it will act as a flush point to remove those impurities. Got it?
Okay.
Okay, so coming to the next question of centrifugal pump. Why do we keep the discharge valve shut in a centrifugal pump? Can anybody explain?
To decrease the amount of current drawn by the motor.
Yeah, that is also a reason. Can you explain the whole answer? What is happening
Can
if
I?
yes,
Um,
Samir, you
initially,
can answer the question after Ashok has completed. Yes, please.
Okay.
Yeah.
if the flow is increasing, the current drawn will also increasing. So initially, we have to shut the valve to avoid the flow, and impeller will get certain reach certain RPM, so that current drawn will be less, and then we slowly, when impeller attain some RPM, attain RPM, attain at constant RPM, we slowly open the discharge valve.
Yes.
That's it.
Yeah. And Samir, you want to answer?
Yeah, I would like to try.
Yes, please.
Uh, Before starting centrifugal pump, we shut discharge valve because to save power consumption. As we all know, when we start the motor, we required some starting torque to rotate the impeller, which is at its rest position. Uh, so, uh, to rotate the impeller, when we start the motor, it draws the lot of current as maximum current, and to develop that momentum and required starting rotation at fixed RPM. As the discharge valve is shut, maximum current is drawn by the maximum current is drawn by the motor to rotate the impeller. As because of discharge valve is shut, it gets reducing after some time slowly. Hello.
Yes.
Yes.
Viraj, you want to answer the question?
Yes. Yes. I explain with example.
Yeah, yeah, yeah. Just
Okay.
1 minute. I want
So
to
we have. Yes.
tell Samir that he have not mentioned the when flow is taking place to the eye of the impeller, the current drawn will also increase, right? Have you mentioned that part?
Yeah, yeah, yeah.
Okay, okay, all right, sorry. Yes, sir, yes.
Yes. Uh, so we have a motor which is rotates the pump at high RPM, which is maybe 4050 RPM. Okay, it's taking 5 ampere current. If we increase the load, then the current also increases. Okay. Then similarly in centrifugal pump, motor rotates at for 1040 rpm. Okay, when the impeller is connected to the motor shaft, which will rotate at high speed. But when flow is increases, then the current also directly increases. It means it take current directly. So we shut the wall for that reason.
To reduce the excessive current drawn because of the flow that is taking place, correct? Yes.
Yes.
Yeah. Akshay, yes, you want to answer?
No, sorry, it was by mistake.
Okay, okay, all right. So I would like to answer this question as in the same way. Like when we keep the discharge valve shut in a centrifugal pump for two reasons: to reduce the power consumption and to save the windings because of the heating effect of current. So at first, when the impeller is we need to when we start the motor, it rotates the impeller, right? So but the impeller is in a stationary position. So a higher starting torque is required to rotate the impeller and bring it to a fixed RPM. So the current drawn is much higher. And on the other hand, when we know in a centrifugal pump, when the flow is taking place through the eye of the impeller, the current drawn increases. So we keep the discharge valve shut so that we can minimize the excessive current drawn that is taking place through the eye of the because of the flow that is taking place to the eye of the impeller. Got it? It's the same answer that you have said. So I think we can move on to the next question, or somebody else want to answer this part. Okay, let's move on to the next question. Is when will the current drawn increase in a centrifugal pump? Is it when the pressure will increase or the flow will increase?
Flow will
When the
increase.
flow is increased.
Yes, when the flow will increase, the current drawn will be increasing. Yes. So does anybody else any other questions regarding centrifugal pump? I think what's a gland packing? Anybody
The
would like to
seal
answer?
between motor shaft and eye of the impeller to prevent the leakage of water.
Can you please repeat it? And your voice is
Hello.
yes.
Okay, gland packing is the sealing between the motor shaft and eye of the impeller to prevent the leakage of water.
It's fitted between the shaft and the casing, right inside the stuffing box.
Yeah,
Yes,
yeah.
yes, Raviraj.
If there is the same answer, gland packing is used in pump as mean of preventing the leakage at the entry point of the spindle into the wall and shaft of centrifugal pump, which is drive the pump or drive the which is used to operate the wall.
Okay. So anybody else was trying to answer, or should I continue with the answer? So gland packing is twisted fibers that are made up of graphite and PTF. PTF is polytetrafluoroethylene, and it is wrapped around the shaft fitted inside the stuffing box to prevent leakage to the pump. Okay, you can mention this part that it is twisted fibers which is wrapped around the shaft, and the materials used are graphite and PTFE, polytetrafluoroethylene. It has two properties. That's why these materials are used. That is, it has low coefficient of friction. So it has less friction. Less friction will be generated. That's why this material is being used. And for graphite, I need to confirm that answer. I also don't know the proper answer why graphite is being used. One is PTF, polytetrafluoroethylene. And what is mechanical seal? Anybody? What is mechanical seal? Anybody? Ashok, Vaishak, Shreyas, Samir?
That's also seal is to prevent the leakage between the shaft and the pump,
Yes, the
but it
function
is
is same, but how
permanently
it is
sealed.
working?
The seal is permanent. In gland packing, seal was a temporary seal.
See, in mechanical seal, it's a two-piece component. One is the rotating part and one is the stationary part. So one rotates and one is stationary. Okay. The shaft is fitted with the rotating part. So when the shaft rotates, the rotating part rotates and outside part is the stationary part. Got it? And it prevents leakage from the pump. There's a O-ring is also fitted. There may be a question, where is O-ring fitted in centrifugal pump? The O-ring is fitted in mechanical seal. There is two O-rings fitted in a centrifugal pump. In a mechanical seal, there are two O-rings fitted. One is with the rotating part, the shaft and the rotating part, and the other one is the stationary part and the casing. In between the casing and the stationary part. So there are two O-rings fitted. Got it? And it is
Okay.
designed to fit tightly so that it can prevent any kind of leakage. Can anybody name the differences between a gland packing and a mechanical seal? Anyone? Please answer, guys. Anybody? Ravi, Raj? Yes, Besak?
No, I don't know.
Okay, so
Can I?
yeah, sure, please.
Mechanical seal was a permanent seal, and it has a less maintenance and then costly, and then that's it about I know about mechanical seal. And then gland packing was a temporary seal. We have to maintenance was high, and then cost was less.
Okay.
That's the difference I know.
See, in gland packing, we require more maintenance, and in mechanical seal, less maintenance is required, and it's easier to replace. In a gland packing is easier to replace, and a mechanical seal is more hard to replace, and more maintenance is required because the gland packing gets compressed, right? We tighten the bolts that are present in the stuffing box so that we compress more the gland packing, right? After some uses, so more maintenance is required in a gland packing, and less maintenance is required in a mechanical seal. And the gland packing allows a little bit of liquid to pass through it, but a mechanical seal provides a much better sealing, and it doesn't allow any liquid to pass through it. It provides a more tighter seal. And gland packing is used where the fluid is non-hazardous. A mechanical seal is used where the fluid is hazardous. We can't use a gland packing where where the fluid is hazardous. If the fluid is hazardous, we only use a mechanical seal. And any other differences is, I think that's it. Yeah. Let me see if I have written any other differences in my copy.
Mechanical seal is expensive than gland packing. Huh?
Yes, mechanical seal is expensive. Yeah, correct. Yes, one more. A gland packing generates more heat and friction, but a mechanical seal generates less heat and friction. So it's in the mechanical seal is better in that way too. I think those are the differences. So can anybody give me the differences between a centrifugal pump and a positive displacement pump? Anyone?
In centrifugal pump, the pressure created is lesser than as that of compared to the positive pump.
Can you
In
speak just little
centrifugal
bit
pump,
more louder?
the
Hello?
just a second, just a second.
Okay, okay.
I'm traveling actually the police has come. Just a second, I will answer.
Yes, anybody else wants to answer till Akshay is returning?
Hello.
Okay, are you ready, Akshay?
Yes,
Okay, please
actually,
go on.
in centrifugal pump, the pressure created is less as compared to the positive displacement pump. The positive displacement pump discharges the constant amount of fluid at a time. In positive displacement pump, there is a reciprocating action happening, whereas in centrifugal pump, there is no fixed amount of mass that is discharged. And yeah, that's it. That's what I want about positive displacement.
Okay. You said reciprocating is happening in positive displacement pump, right?
Hello.
Hello?
Yeah.
Okay. You
Hello, am I
can.
audible?
Yes, yes, now you're audible, but your voice is breaking in between.
Yeah, actually, I am traveling,
Uh,
so there is no network.
all right, okay. Yes, who wants to answer this question? Please go on.
Hello.
Yes.
Yeah, centrifugal pumps is a type of rotodynamic pump and works on principle of centrifugal force. And whereas positive displacement pump is works on a positive displacement, whereas application of centrifugal is where we need high flow and low pressure is required. There we use centrifugal pump, and where we need low flow is required and high pressure is required. There we use positive displacement pump. In centrifugal pump, efficiency is depend upon flow, depends upon Q, means flow. More the flow, and in centrifugal pump, the flow is more, the efficiency will be more. And in positive displacement pump, the efficiency is constant as flow is constant. Centrifugal pump requirement priming is required, and in positive displacement pump, priming does not required. Uh, in centrifugal pump, there is no relief valve. Positive displacement pump, there is relief valve. In centrifugal pump, suction and discharge are at perpendicular angle, like at 90-degree angle. And in positive displacement pump, flow is in straight line, or let's say in parallel. That's it, I know.
The last point in positive displacement pump, but in rotary pump, it's not in parallel, right? Not the flow is not in straight line, right?
Yeah, okay.
In a rotary, that is also rotary pump is also a positive displacement pump, right?
Yeah,
So
yes,
you
yes,
can
yes.
add one more point, that is a centrifugal pump can handle liquid with impurities, but a positive displacement pump faces trouble while handling liquid with impurities. I
Imperial.
think you have not mentioned this point, right?
No, no, I have not mentioned
Relief
this one.
valve you have
Okay.
mentioned. Let me check if there are any other differences in a positive displacement. Yes, I think that's it. I think you have mentioned all the other different points. Yes. Yes, one more point.
Centrifugal pump can pump only water or can pump oil.
Yes, centrifugal pump can't handle gas, right? Correct. And centrifugal pump also can't handle high viscous fluid. A positive displacement pump can handle fluid with a higher viscosity. This is also a difference. We can add it in our explanations.
In main engine, we use centrifugal pump
For
as a
lubrication,
lubing,
yes. For two-stroke engine,
but
we
it is of high viscosity, na?
yes the lubrication.
There is a two types pump we use. One is the gear pump used for the positive displacement. We used in above the stuffing box because of
Oh,
Gear
I'm
pump is
talking
used
about
in
the
four-stroke
crankcase oil.
lubrication, right?
no, two-stroke.
In two-stroke too.
Two-stroke
Crankcase
main
oil is
engine.
pumped by the centrifugal pump, na?
Crankcase oil is pumped by
Pump. Yes,
centrifugal
yes, yes.
pump.
Got it, got it. You were saying about the gear pump is used for the cylinder oil, right?
Yeah.
Okay, okay, got it. But
But crankcase
yeah,
oil
crankcase
have
oil
high
is viscous.
viscosity
Yes.
or low viscosity.
Yeah, it's the exact viscosity amount. But yeah, it is. It has a little bit of viscosity. Uh, no, we have not discussed
Okay.
compressor till now. I think compressor today is only pumps. Compressor, I think. What's the next? What should be the next topic for tomorrow? Could it be compressors?
Maybe air compressor because of lot of topics not covered in air compressor.
Yeah. We can get into compressors because in Dreamers 2 only multi-stage compressor is explained, right? And I think he was
Yeah.
what was your name? You just messaged, right? Let me see. You were asking the same thing in group 2, right, Gaurav Malik? Yeah, I have seen your message, but to confirm it, I have to ask somebody which one should we, uh, which uh, which answer should we give for the classifications of compressors. I think your one is much better, but still I have to confirm from someone. I will try to confirm it tomorrow.
Okay.
So what's the next question? Does anybody have any questions regarding centrifugal pump? I think lanterning, yeah. Cavitation, how does cavitation takes place? Anybody? Who wants to answer?
When the suction pressure of the pump is below the vapor pressure of the liquid being fed, vapor bubbles are formed. When these bubbles get into the high pressure side, that is discharge side, they burst. It causes a pitting action to the casing. It will damage the pump. This is known as cavitation.
Okay. Your answer was correct. You
May I?
can add one or two more points. Yes, Ashok, please. Yes,
Cavitation occurs when
Naviraz, I'm coming to you.
liquid turns into vapor at a low pressure. It occurs due to low it occurs due to insufficient net positive suction rate. So in a, in order to when cavitation occurs at low pressure, liquid is turns into vapor, and then it's form egg bubble. When it egg bubble goes to low pressure side to high pressure side, discharge side, it it will implode. It will implode, and then vibration occurs. The vibration is the impeller, so impeller will be get damaged more. So this was, and then efficiency will decreases, and then pump will get damaged.
Correct. What was your starting point when the suction pressure? You didn't say. You have you told vapor pressure when the suction?
Yeah. I have told where liquid is converted into vapor when insufficient net positive suction rate available.
Okay. Raviraj, yes.
Yes, the cavitation is the formation of bubbles in the flowing liquid due to local fall in fluid pressure. This is called as cavitation. Okay. So the reason of vapor formation is low pressure at the suction site. We know the water vaporize at or water boil at low pressure. Okay. So so the in case suction pressure will be 0.8 bar and water temperature will be 50 degrees Celsius, then the water will be vaporized. So it is the reason of bubble formation. Am I right?
Yes, you are right. Bubble formation and then implosion will take place, right? When these vapor bubbles will pass from low pressure region to high pressure region. The low pressure region is the impeller eye, and the high pressure region is the discharge side, correct, towards the casing. That is the high pressure region. Then implode, this bubbles will implode and it will create a shock wave, and this shock
Okay.
wave will hit the impeller, due to which cavities will be formed in the impeller and it will damage the impeller. That's why we need to avoid cavitation. And
Okay.
why is the bubbles getting created? As the pressure will get below the vapor pressure, due to which the water will vaporize and then bubbles will be formed. Right? Yes, your explanation was correct. Just add that part too. And for definition, you can say that cavitation is the rapid formation and subsequent collapsing of vapor bubbles that are formed in that inside a pump when the suction pressure gets below the vapor pressure of the pump. For definition, you can say that, and then go into how the bubbles are getting created. Why is the bubbles getting created? Why is the suction pressure getting? Why is the suction pressure drop? Like getting below the vapor pressure? Can anybody explain?
May I?
Yes, yes.
Net, there is a suction pressure, which means a low pressure side. If the vapor liquid turns into vapor at a low pressure side, which means the pressure at which liquid will get vapor. So vapor goes into the pump. It will create a bubble, air bubble. So it will go low pressure side to high pressure side, and it will implode.
But why is the suction pressure getting below the vapor pressure? Can anybody explain that one? Raviraj?
Yes. Another reason is vapor formation at high local velocities. Okay. At
Yes, yes,
high
high
local
local
velocities.
velocities. Correct, got it, got it. You said this
Yes.
point earlier
Yes.
too, right?
Okay. Yes.
Yeah, yeah, yeah.
The region kinetic energy is increases at high local velocity. Okay, and pressure decreases. So the low local pressure region, it will produce bubble.
Yes, yes, got it. This part, your answer is much better. We can use your answer too, because of the higher
Okay.
velocity
Yes.
at one part.
Yes.
That is the I, right? Then the suction pressure will get below the vapor pressure, and then bubble water will vaporize and bubbles will be formed. Okay, so now we can move on to
Sorry,
NPHs.
can you repeat that?
The cavitation answer. Raviraj, can you explain the
No,
starting part?
no. How the pressure is decreased below the vapor pressure?
So when the fluid will pass, when the liquid will pass with a higher velocity in that region, the suction pressure will get below the vapor pressure. Am I right, Raviraj?
Yes. Yes.
In centrifugal pump, how the velocity is much higher now?
Uh, Due to increasing area, velocity decreases.
I think he is asking for like how is the velocity increasing, right?
Yeah, yeah.
Raviraj, do you have any explanation why how is the uh, velocity getting increased?
No, 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 sir.
Yeah, I will have to find it. How is the velocity getting increased? But I have read it somewhere. The velocity increases. That's why the pressure drops below the suction pressure. I am unable to use my speaker. What should I do? That's all right. If you don't, if your speaker is not working, you can just message it if you have any answers. Okay, that's all right. You can just type in your message. It's all right. Yeah, why is the velocity increasing? I need to find it. So I think we can move on to NPHs. Can anybody explain what is NPHs? Anyone? Guys, please speak. Pradyuman?
NPSH stands for net positive suction head.
Suction head, yeah.
Basically, it is the measurement of suction pressure in the pump, which is supposed to be higher than the NPSH available. Sorry, NPSH required.
NPHs available, required, okay. Anybody else wants to answer this question? What is NPHs?
To prevent the cavitations, NPSH will be using net positive suction head available is always greater than net positive suction head required. This how cavitation can be prevented. Am I right?
Yes, correct. And NPHs available should be. Yes, who wants to answer?
No, sir, I don't have any answer. I just have a question that what actually happens when bubble forms on the discharge side of any pump?
When
That
on
causes that causes cavitation, right?
Yes, that causes cavitation if the bubbles are
So,
forming in the
so the
suction
mic,
side.
no, sir. Let me complete.
Yeah, yeah.
My question is how the cavitation can pump? Why it is so dangerous for the pump?
How the cavitation is what? Can you repeat the last part of your question?
Can affect our pump, or you may say motor, whatever it is working.
See, the cavitation must be avoided because after the bubbles are formed, when these bubbles are formed with the eye of the impeller, right? It is a low pressure region, and when it will pass to the volume casing, it's a high pressure region. So the bubbles will implode, right? And it will strike the impeller, due to which cavities will be formed. I will just show you the cavities. I will just share my screen and show you the cavities that are forming in.
Sure.
Just 1 second. I'm trying to find it. Pop up.